recording. Good morning, grade 8. Okay, we are still in the continuation of our topic, faults and earthquakes. Let's move now to causes of earthquakes. Okay, what are the primary causes of earthquakes? Let's find out. The Earth has four major layers. Okay, we have the inner core, outer core, okay, mantle, and the crusts. Okay, if you're going to look at it in a hierarchy, the outermost part, okay, is the crusts, okay, followed by mantle, outer core, and the inner core. Okay, the crusts and the top of the mantle make up a thin skin on the surface of our planet. Okay, but the skin is not all in one piece. Okay, it is made up of many pieces like a puzzle covering surface of the Earth. Okay, not only that, but these puzzle pieces keep slowly moving around, sliding past one each other. Okay, or one another, and bumping into each other. We call these puzzle pieces as tectonic plates. So we are actually located in different tectonic plates, right? And the edges of plates are called the plate boundaries. Okay, hence we have plate tectonic theory and the plate boundary theory. Okay, plate boundaries are made up of many faults, and most of earthquakes around the world occur in these faults. Since the edges of the plates are rough, they get stuck while the rest of the plates keep moving. Finally, the plates have moved far enough and edges unstick on one another or one of the faults, and there is an earthquake. So if there are some bumping, sliding, what else? Moving of plates tendencies, it actually creates earthquake. Okay, if you're going to look at a slice or a longitudinal section or longitudinal cut of Earth, you can actually observe that there is a crust, a thin covering. We have a mantle, the inner core, the outer core rather, and the inner core. Okay, while the edges of the folds are stuck together, the rest of the block is moving. The energy that would normally cause blocks to slide past one another is being stored up. Okay, when the force of the moving block finally overcomes the friction in the jagged edges of the fold and it unsticks, all the stored energy or stored up energy is released. Hence, we created or it creates earthquake. The energy radiates, okay, just like the ultraviolet rays or your EM or electromagnetic waves. It radiates outward from the faults in all directions in the form of seismic waves. Okay, like ripples in the pond. Have you tried dropping a rock on a pond? It creates a ripple effect. It looks like a ripple effect. Okay, earthquake radiates. Okay, it radiates from all direction. The energy there radiates from all direction, making what? Making a seismic wave. Okay, the seismic waves shake the earth as they move through it, and when the wave reaches the earth's surface, they shake the ground and anything on it, like the houses or even us. Okay, that's how earthquake actually generated. Question: why do we need to have earthquake? Okay, if this earthquake is damaging to nature and damaging or can cause damage to humanity, why do we need to have earthquake? What's with the earthquake? Any idea? Any idea? Oh, by the way, talking about your activity, okay? I already checked all your activities from the previous quarter, and upon checking, a lot of you didn't actually do their activity, and of course, the offline students also didn't submit their modules or the activities from their modules. Well, it's up to you. It's definitely up to you. Okay, I already created your grades, and of course, what you actually gain is as is. It's there already. It's there. It is already recorded, right? A lot of you also don't have performance tasks. Remember that your performance task is 40% of your grade. So most probably you might be fail in my subject, or you might fail in my subject if you don't have an output or your performance task, your report sheet. I didn't actually ask for a project for this quarter or for the last quarter, simply because I want you to focus on the performance task that I had given to you, okay? The report sheet. And only few actually submitted. So it's okay, right? It's okay. I will not force you to do so. As long as there is no blaming and there is no asking for grades at the end of this quarter, at the end of the school year, right? Again, I already given you a lot of chances, and those chances are precious, right? Those are precious chances that I had given to you. Okay? You cannot blame me for your grade. Okay? I'm striving really hard in order for you to learn a lot, even though this is really pandemic, or this we are still in a pandemic situation. And as of the moment, we cannot actually make a reason that this is pandemic. Well, definitely COVID will not be eradicated all throughout. We'll be living with it, and you will know how to deal with it. As simple as that. Let's move forward. Okay. Intensity and magnitude. Okay. Intensity and magnitudes are the measurements. Okay. Take note. These are the measurements that we actually use in order for us to gauge the strength and the damages created by a certain earthquake. Simple as that. The size of an earthquake depends on the size of the fault and the amount of slip on the fault, but that's not something scientists can simply measure with a measuring tape. No, it's not that easy to measure, since faults are many kilometers deep beneath the Earth's surface. Correct. So, how do they measure an earthquake? They use a seismogram or seismogram recordings made on the seismographs at the surface of the Earth. To determine how large the earthquake was, a short wiggly line that doesn't wiggle very much means a small earthquake, and a long wiggly line that wiggles a lot means a large earthquake. Okay? The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of the slip. So, it depends upon the recording, the seismogram recording. Again, in the recording, okay, it has short and long wiggle line, okay, or lines created by the seismogram, okay. A short wiggly line that doesn't wiggle very much means that the earthquake means a small earthquake. So it is, if it is really short, then it is just a short earthquake. And a long wiggly line, which means or wiggles, the wiggles a lot, means a large earthquake. The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of slip. That's how we measure an earthquake. The size of an earthquake is called its magnitude. Okay. Again, the size of an earthquake, which is actually measured by your seismogram, okay, is actually called magnitude. There is one magnitude for each earthquake. Scientists also talk about the intensity of the shaking from an earthquake, and this varies depending on where you are during an earthquake. Magnitude measures the energy released at the source of the earthquake or an earthquake. Okay, magnitude is determined from the measurement on seismograms or seismographs. Intensity, on the other hand, measures the strength. Okay, measures the strength of shaking produced by earthquake at a certain location. Okay, if magnitude measures the energy released, okay, intensity measures the strength of the shaking produced or the damages by the earthquake at a certain location. Intensity is determined from the effects on people, how many houses are being destroyed, human structures, buildings, and the natural environment. Again, magnitude measures energy release and intensity measures the strength. So meaning it resembles what? Or it includes effects on people, structures, natural environment, buildings, and so on. Seismograms come in handy for locating earthquakes too. Okay, and being able to see P wave and S wave is important. You learn that P and S waves, or primary waves and secondary waves, each shake the ground in different ways as they travel through it. P waves are also faster than S wave. Okay, and this fact is what allows us to tell where an earthquake was or where the earthquake started. To understand how this works, let's compare P and S waves to lightning and thunder. Light travel faster than the speed of sound. So during a thunderstorm, you will actually see a lightning first. This is the reason behind. Lightning first, and then you will hear the thunder after how many seconds. Okay? If you are close to the lightning, then the thunder will boom right after the lightning. Okay? But if you're far away from a lightning, you can actually count several seconds before you hear thunder. Therefore, or the farther you are, okay, from the storm, okay, the longer it will take between the lightning and the thunder. So meaning to say, it depends upon the distance, your distance. This is how we actually predict, okay, certain geologic events like earthquake. This is how we actually predict earthquake, the location or the geologic location of a particular earthquake. Okay, this is actually P and S wave. Okay, this is P wave and this is S wave. P waves are like lightning and S waves are like thunder. So meaning to say, P waves is faster than S waves. So you can actually feel first the P wave. Okay, you can actually feel first the P wave after, okay, followed by S waves. P waves travel faster and shake the ground where you are first. Then the S waves or secondary waves follow and shake the ground also. If you are close to the earthquake, the P and S wave will come right after one another or the other. But if you are far away, there will be more time between the two. Okay? If you're going to look at the movement of P wave is shaking. Okay? But the S wave is up and down. Okay? P wave is moving left and right. Okay? S wave is moving up and down. Okay. I think we already finished discussing this. Do you have any questions so far? Questions so far? Let me discuss about your second mastery test. For your second mastery test, the coverage are the following. Okay. Types of faults. Okay. Earthquakes. Earthquake focus and epicenter. Primary waves, secondary waves, causes of earthquakes or earthquake, intensity and magnitude. Right? Those are just your coverage for the second mastery tests. Again, I am already done recording your first quarter activities from module 1 until module 2. Right? And a lot of you also, as what I had observed, a lot of you just copy pasted some from the internet. I don't want copy pasted materials. And some of you also had given me an answer which are off tangent to the lesson proper. I don't know why. Where did you get those information? And that is not related to the topic. That is why I'm wondering how. How did you generate those informations? Which is off tangent to the topic. Okay, again, please do not give me a copy-pasted materials because I have seen a lot of copy-pasted materials. Why do I know? Because I read a lot. And some of them, I already encountered them. Again, the next time that you'll give me a copy-pasted material, I will just mark it 0, right? But for now, I already given you a grade. Can you check on your LMS on the previous quarter? First quarter, module 1, okay, weeks 1 to 4, and first quarter, module 1, weeks 5 to 8. Please check on your activities. It is already being checked, okay? All of your activities are already recorded. Okay. Do you have any questions so far? All right. Again, I think that will be all for today, class. Expect a series of activity by next meeting, right? I think that will be all. Have a nice day, everyone. Take your lunch. Bye-bye. Take care.